Problem number 5. So here we have an array of elements that appear twice except one, and we have to find that element that appears just once in the array. So we have to solve this problem within log n time complexity, meaning that we have to find out element using binary search. For it, we will need 2 pointers, low and high. Low will be pointing at the first element of an array, and the high will be pointing at the last element, but according to the search, it will always divide our array by 2 and decide at which side of an array is the element we are looking for, at the left side or at the right side, and according to the result we will decide in which direction to move. And once 2 pointers will be equal to each other, we will just return value of 1 these pointers, for example low in my case, because it will mean that the element that we're looking for is finally found. And since all elements appear twice, while our search, we always have to compare with the elements that is next to the elements that we're pointing at, making sure if the order is broken or not. If the order is not broken, we will keep, if the order is not broken, like here 1 1 3 3, meaning that the element we're looking for is at the right side. If we see that the order is broken, meaning that the two next elements are not equal to each other, we will keep our search at the left side. So for example, if the index is odd, we will compare it with the previous element, and we see if 2 elements are equal to each other, the order is not broken, and we will need to keep our search at the right side. If we see that the order is broken, we will need to compare to continue our search at the left side, meaning changing our value of high pointer, decreasing it. Changing our high pointer by decreasing our index value by 1. When we see that the index value is even, we will need to compare it with the next element. If the element that we are pointing at and the next element is equal to each other, meaning the order is not broken, we will keep our search at the right side. Otherwise, we will just keep our search at the left side of the array. So in that particular example, it will work like this. So we have 11 elements, 11 divided by 2, rounded down to 5. We will compare. We see that the index that we're pointing is odd. We need to compare it with the previous element at index 4. We see that they are not equal to each other, meaning that the order is broken. So we will keep our search at the left side of an array, and we will search elements from 0 till 4. So in that case it will be 4 divided by 2, it will make 2. Our pointers will be lower 0 and high is 4. So we see that the pointer is even, so in that case we'll compare it with the next element at the third index, and we see that the element in the second and the third indices are equal, so meaning that the order is not broken. So we will keep our search at the right side. So in that case we'll just change our lower pointer by decreasing our actual pointer by 2. At this point we will see that our lower pointer is 4 and lower pointer is equal to our higher pointer, which is also 4, and at that case we will just return value of one of these pointers, and it will be actual result that we are looking for. And in function it will be like this, so we will return an integer. I will call find distinct. Passing argument will be array. So here we will need our pointers. Lower will be pointing at the first element, and the high pointer will be the last element of an array. So I will use while loop, and I will run my while loop until low pointer is less or equal to high pointer. And after that I will be calculating the midpoint, the index that we will be pointing at. It will be basically like high pointer minus low divided by 2 plus low. So, and first thing, yes, I just forget to write it. I will return one of the pointers once my high pointer will be equal to low pointer. Otherwise, I will keep running. I'll keep running and will compare the pointer that will, and compare if the pointer that we calculated is even or not. So it will be basically like mid modulus 2 is equal to 0. If it's 0, it will mean that it's even. In that case, I will just compare the element that we're pointing at with the next element. If it's equal, I will keep searching at my right side, changing my low pointer. Otherwise, I will change my high pointer. We'll be making it equal to the pointer that we're looking at. Otherwise, else if mid is odd, like is not equal to 0, meaning that it's odd, in that case I will compare my element with previous element. If it's equal, it will mean that the order is not broken, and I will need to search at the right side, changing my lower pointer. Otherwise, if order is broken, I will change my high pointer. So once my for loop will get to the end and lower pointer will be equal to the higher pointer, will mean that we find out that distinct element that appears just once in the array. Otherwise, if it's not found, I will just return -1. So time complexity of this approach is O log n, and the space complexity we define just 2 pointers, and we also define it one in middle pointer, but all of them are constant values, and we can say, and we're using the existing array, and we can say that the space complexity is O constant.